Okay, so we've looked at this common multiple, least common multiple. And as you probably guessed, that leads us up to that least common denominator. We looked back at the first day of class. We had something like 1/4 plus 2/5. And we said we couldn't add those because when we add numbers, we must have the same name. Remember our qualifications for adding or subtracting. One is we must have the same name. Unlike our multiplication and division where we did not need the same name, to add or subtract, we must have the same name. And for fractions, that comes down to the common denominator. Second, we're going to keep the same name. So, whereas in multiplication and division, we combine the names, for adding and subtracting, once we get that common name, that common denominator, we keep that same name. So with something like 1/4 plus 2/5, first step is to figure out what that common denominator is, what that same name is going to be. So to do that, we look at the two denominators we have, the 4 and the 5. And there's a couple of ways we can go about this. The shortest way to do it is just multiply. 4 times 5 is 20. So we're going to have a common denominator of 20. Now that's not always going to be the smallest common denominator, that least common denominator, but it will be a common denominator. And as we do examples, we'll take a look at what happens if we just do that every time. And we'll still get the correct answer, it's just a little bit more work. The second option is to take our two denominators and just make lists. Counting up by 5s, we know that 5 is going to be 5, 10, 15, 20, 25, and so on. 4, well, we add 4 would be 8, plus 4 would be 12, plus 4 is 16, plus another 4 is 20. There's our winner right there. We've got a common denominator of 20. Of course, we can also do what we were just doing. We could factor. Now, 5 is prime, so it doesn't factor out. So it wouldn't be very interesting to factor those to get a common denominator. So anyway, let's do our 1/4 plus 2/5. And we found that our common denominator is 20. Now when I add and subtract, I always set them up vertically just because that's how my mind works. But whatever works best for you, go ahead and do. So what did we have to do to the 4 to turn it into a 20? Multiplied by 5. Yeah. So what do we have to do to the 1? We have to also multiply it by 5. Remember, when we rename a fraction, we either multiply or divide the top and bottom by the same number. So if we multiply the denominator by 5, we have to multiply the numerator by 5. Here, what did we do to the 5 to turn it into a 20? Multiply by 4. So what do we do to the 2? Times 4. 2 times 4 makes 8. So now we have the same name. We have 5/20ths and 8/20ths. They're both 20ths. And now we can add by combining the counts. 5 plus 8 is 13, and we keep the same name, 20ths. So 13/20ths is the result of that. So here we've got 1/8 and 5/6. Again, I'm going to write them vertically. Now we need to find a common denominator. With the numbers, some of you may be good at just looking at them and figuring out what that common denominator is. But I'm going to go ahead and factor these. 8 is factored into 2 times 2 times 2. 6 factors into 2 times 3. So if I look at them, they both have a 2. What does the 8 need up here? Needs the 3. Now they both have a 3. The 6 needs to have 2 more 2's. Now they're identical. So this is 8 times 3 is 24. 6 times 2 times 2 is also 24. So my common denominator will be 24. What's this going to become right up here? 3. Very good. It was 8 times 3 to make 24. So 1 times 3 makes 3. What's this going to be? 20. Good. So we have 6 times 4 makes 24. So 5 times 4 makes 20. So now we have the same name. They're both 24ths. We're going to combine the counts. 3 plus 20 makes 23. And we keep that same name of 24. So it's 23 24ths. Now, I promised you I'd show you an example of this. This is a good problem to do that on. What if I just did 6 times 8 is 48 and use that as my common denominator? Will that work? Sure it will. It's just a little bit more work. So now it's 8 times 6, so 1 times 6. This will be 6 48ths. What's this going to be? Six times 8 makes 48, so 5 times 8 would be 40. So we're just going to add. 6 and 40 make 46 48ths. And of course, what do you need to do with that? Both need to divide by 2. So we got 23 24ths. So you get the same answer either way. It's just here we have to do that extra step of reducing it once we get the answer. Okay. We might have something like this. 3/4 plus 1/12. What's my common denominator going to be? 12. Yes, bless you. Sometimes one of the denominators is the common denominator. If one of the numbers divides into the other one, then that larger one is the common denominator. So what's this going to become? 9, yes. 4 times 3 makes 12, so 3 times 3 makes 9. How about this one? It's going to stay 1. The 12 doesn't change, so the 1 doesn't change. So now we've got 9 plus 1 is 10. We keep the same name of 12ths. And of course, that needs to be reduced. Both divide by 2, give me 5 6. So just because we use the least common denominator does not guarantee that we don't have to reduce the answer. Just makes it less likely that we'll have to. If we are subtracting, we're going to do the same thing. Like 3/4 minus 2/3. What's my common denominator going to be? 12. What's going to go up here? 9. Good. 4 times 3 makes 12, so 3 times 3 makes 9. What goes up here? 8. 3 times 4 makes 12, so 2 times 4 makes 8. So now that we have common denominators, we go ahead and subtract. 9 minus 8 is 1, and we keep the same name, so it stays 12. So 1/12 is the difference between those. In your notes, I want you to try 5 6 minus 3/8. See what you come up. What's my common denominator? What's our common denominator going to be here? 24. You could have also used 48. That would work. What's going to go up here? 20. Very good. So 6 times 4 made 24, so 5 times 4 is 20. What goes here? 9. 8 times 3 makes 24, so 3 times 3 is 9. So now we've got the same name. We got common denominator. We can subtract. 20 24ths minus 9 24ths. 11. 20 minus 9 is 11. And it's 24. So just adding and subtracting with the fractions isn't too bad to do. What if I have something like this? So we've got 3b over 8 plus 1/4. Well, the first thing I need is a common denominator. What's it going to be? 8. So the 3b doesn't have to change. That's just 3b over 8. What's this going to become? 2, right? 4 times 2 makes 8, so 1 times 2 is 2. So we have the common denominator. We can go ahead and add. Problem is, what is 3b plus 2? 3b plus 2 over 8. Or we might have 2x squared over 5 plus 3x over 4. And we are adding. What's our common denominator going to be? 20. So now it's 5 times what to make 20? 4. So I have to multiply the top by 4. What's 2x squared times 4? 8x squared. Good. What do we multiply the 4 by to make 20? 5. So we multiply the top by 5. What's 3x times 5? 15x. So again, we go to add. We've got common denominators, 20. What is 8x squared plus 15x? Once again, that's just 8x squared plus 15x. I can't combine those. It's over 20. So all I'm really doing is putting the two numerators together over the common denominator there. Any questions? I'm going to have you guys try one of those. Try that one in your notes quick. So what's our common denominator going to be here? 24, good. What's this numerator going to become? 20x. 6 times 4 made 24, so 5x times 4 does make 20x. What's this one going to become? 9x squared, good. 8 times 3 makes 24, so 3x squared times 3 is 9x squared. Then what? Add them together, so 20x plus 9x squared is... We either do 9x squared plus 20x or 20x plus 9x squared. It doesn't matter. Typically, better math grammar is to put the larger power first. So the 9x squared plus 20x over 24 would be the more grammatically correct, but neither one of them would be wrong. Both of those would be correct answers. Any questions on those? Well, let's make it more interesting where the variables now come into play in the denominators. If you haven't noticed yet, there's a pattern in our least common multiples or least common denominators. First of all, the number portion, when we have variables, is going to be the same. What's the least common denominator between 8 and 6? 24. With the variables, If I have a factor of x, and x squared is just x times x, what do I need to do to make those the same? Put another x up here, multiply that by x. So for the variables, the least common multiple is just going to be the largest power. So the largest power here is the x squared. So it's going to be 24x squared is my common denominator, least common denominator. Now I have to ask, what did I have to do to the 8 to turn it into a 24? Multiplied by 3. What did I do to the x to turn it into an x squared? Times x, right? So that's multiplied by 3x. So the numerator has to be multiplied by 3x. So 5 times 3x is 15x. On bottom, to turn the 6x squared into a 24x squared, what did I do to the 6? Times 4. How about the x squared? Nothing. It's already an x squared, so there's nothing needs to be done to that. So 1 times 4 is 4. So now we have the same name. 24x squared is our denominator. We have 15x plus 4 is just 15x plus 4. So 3 over 8b squared plus 1 over 4ab. I need a common denominator. Number, what's going to be the common denominator for the numbers between 8 and 4? Just the 8. Now each variable at a time. Now we should go alphabetical order. How about the a? Remember, it's the higher power. So a by itself is the highest power, so there's just going to be an a in each of them. How about for the b? B squared. So up here, did I need to do anything to the 8? No, it's already an 8. How about the b squared? No, that stays b squared. But I do have to multiply by a. I need to get an a in there. So 3 times a is 3a. On bottom, do I have to do anything to the number, to the 4? Yeah, it's multiplied by what? 2 to make 8. How about the a? Do I have to do anything to that? Nope, there's already an a there, and it doesn't change. The b? Times another b to make b times b to make b squared. So the numerator has to be multiplied by 2b. What's 1 times 2b? 2b. That's what's just going through my head, too. 2b or not. 3a plus 2b is 3a plus 2b over 8ab squared. Any questions? Let's have you try one. Give that one a shot in your notes. See what you come up with. So what's our common denominator going to be? 60x squared. Good. So what's this become here? 35x. Good. 12 times 5 and x times x. So we got to do times 5x up here. Gives us the 35x. What's this become? 30. All I do is 10 times 6. The x squared is already there, so 5 times 6 is 30. So we've got 35x plus 30 is 35x plus 30 over 60x squared. Any questions? Now, if this were a more formal algebra class, technically that's reducible. Right, see, every number there can be divided by 5. The reason for that is this could have been reduced before we started. The 5 and the 10 could have divided out, giving you 1 and 2. If you treated it like that, then you'd end up with 12, which is your common denominator. But for our purposes, this is a perfectly acceptable answer. Okay, let's look at subtraction then again. Let's say we have 7x over 10 plus x squared over 4. It's not plus, minus x squared over 4. So we've got denominators of 10, bless you, 10 and 4. What's our common denominator? Bless you again. What's our common denominator going to be? 20. So 10 times 2 made 20. 7x times 2 is 14x. Down here, 4 times what makes 20? 5. So x squared times 5 is 5x squared. So now what? We've got the, go ahead. Perfect. We've got the 14x plus 5x squared. Technically, we should put the x squared first, so it's 5x squared over plus 14x all over 20. And we can run into something like this. What is my common denominator going to be? Well, for the numbers 10 and 5, the common denominator will be what? 10. For the variables x and x squared, it would be x squared, the larger power. So we don't need to change the 10. That number's already correct. But we have to do what to the x? Times another x to make x squared. So we have to multiply the numerator by x. 3 times x is 3x. Down below here, what do we need to do to change the 5? Times 2. The x squared is already x squared, so we don't have to do anything to that. So the numerator, 2 times 2 is 4. We are subtracting. I put plus up here. I screwed up. I made a mistake up here. Can anybody tell me what it is? It's supposed to be subtracted. Yep. So we could leave it as 14x minus 5x squared. Or you could have done negative 5x squared plus 14x. Yeah. Don't be afraid to call me out on those.
I'm pretty sure I told you to put plus.
Did you tell me to put plus?
I'm thinking I did.
Okay. I'll take the blame for it. I still should have caught it. So our denominator here is the 10x squared. Oops. Is the 10x squared. What's my numerator going to be? 3x minus 4. Very good. Any questions? Okay, well, I'm going to give you the last 20 minutes if you want to get started on the quiz next door here. There will be a new quiz that is due tomorrow. That'll be Tuesday at 11:59 p.m. And there's a new homework. It'll be due Wednesday in class. I I suggest you do the quiz first because the homework is on the stuff we just did in class. So before you get your mind too deep into that, I suggest you do the quiz on the stuff from last Wednesday and Thursday first. Okay, so the computer lab next door is available if you want to start working. Otherwise, we'll